Next educational video. Let me show you more examples on limits of sequences. And these examples are more complicated ones. We need more tools and results. So here are 4 commonly used results on limits of sequences. 1 and 3 are pretty obvious. 2 and 4 are not quite. To prove them, we need more advanced tools. Our job is to learn how to use them. Quite often we need some of these so-called limit laws that tells us how to find limits of a combination of sequences. Here are 2 sequences AN and BN. They are convergent and they have limits AB respectively. So this law tells us how to find limit, for example, of a sum of these 2 sequences. So it turns out that limit of AN plus BN is just the sum of the 2 limits, as expected. Law number 3 is about product. Law number 4 is about the ratio. Number 5 is about composite functions. If you want to find limit of a function of AN, all you have to do is to take the functional value of f at the limit of AN. Let me show you an example on the use of 5. Take AN to be 1 over n. We all know that 1 over n converges to 0. If you want to find the limit of cosine 1 over n, all you have to do is to take cosine of 0. And the answer is 1. So this is what law number 5 is about. With these results at our disposal, we can now find limits of complicated sequences like those you see in these examples. We begin with part 1. Inspecting the sequence, we immediately know this is a difference of 2 sequences. So we apply law number 2 to split this up into the difference of 2 limits. We also apply law number 1, taking out number 5 from the second sequence. So here little c is 5. Next, we're going to do something about the first sequence. 3n power 2 over n. 3 and n should be split into 2 because each has its own formula to apply. So we split this up using integers law. And furthermore, 2 over n can be written as 1 over n power 2. So this is to prepare us for the use of the standard results that I'll show you later. It's time to address this power 2. Obviously, we are finding the square of a sequence. So according to limit law number 5, limit of function of an is just the function of the limit. So essentially, we are squaring the limit. We are now ready to apply the standard results on limits. So here is the list of the 4 results. It turns out that we need to use 3 of them. This requires careful inspection. For the first term, 3 power 1 over n, this is of type number 1, a constant power 1 over n, the one I circled in red. The second one is n power 1 over n, so that is from result number 2. And finally, 1 plus 2 over n power n is of the form 1 plus a over n power n with a equals to 2. So we apply result number 4. So in the end, we get 1 times 1 minus 5 times e squared, the final answer. Let's look at the second example. Inspecting this sequence, we can tell it is result number 4 that we need to use. However, there's one hurdle to clear. In order to apply result number 4, you have to write this term in the form 1 plus a over n. So what we do is, we write 1 minus 3 over 2n as 1 plus minus 3 over 2, which is going to be the little a divided by n. Just do a quick check, these two are equivalent. We also need to address this power minus 4n. In formula number 4, the power has to be n. So it's a standard trick that you write first power n, followed by power minus 4 outside. So this is just a simple use of the indices law. And finally, we will address this power minus 4. Essentially, we are finding limit of a sequence raised to the power of minus 4. And by virtue of result number 5, we can raise power minus 4 to the limit. So we are applying result number 5 with the function equals to x power minus 4. And now the one in green is nothing but e power minus 3 over 2, which is the result number 4 that we saw earlier. And then we raise it to power minus 4, resulting in the answer of e power 6. And we are done.